All right, today we're going to tackle something that's really at the core of a lot of the tech we rely on every day. It's an algorithm called Raft, and it was built to solve a huge problem in computing. But its secret weapon, well, it isn't some crazy complex math, it's actually something much more human, being easy to understand. So what if the best feature of a system wasn't its power, but just the simple fact that you could actually wrap your head around it? That's the big idea behind Raft. So let's start with a really fundamental question. You've got a bunch of computers all trying to work together on the same task. How do they all agree on what's true? Especially when things inevitably go wrong. Servers crash, networks get flaky. How do you stop everything from descending into chaos and make sure every machine has the same correct information? Well, this isn't just some thought experiment. It's a massive challenge in computer science, and it has a name, the agreement problem. And solving it is absolutely key to building reliable systems in a world that is, let's face it, pretty unreliable. And the formal term for solving this agreement problem is consensus. The whole point of a consensus algorithm is to get a group of computers, or servers, to agree on something, a single value, an order of events, whatever it is. But here's the most important part. Once a decision is made, it is final. It's set in stone. That finality is the bedrock that lets us build systems we can actually trust. So what do we do with this? Well, the ultimate goal is to build something called a replicated state machine. It sounds fancy, but the idea is simple. You're trying to make a whole cluster of normal failure-prone servers act like one single super-duper reliable machine. Every server keeps an identical log of commands, and consensus makes sure they all agree on what those commands are. And, this is crucial, the exact order to run them in. That way, even if a few servers go offline, the system as a whole just keeps on chugging along correctly. For a long time, the main way to do this was with an algorithm that was, let's just say, famously complicated. This made it really hard for people to use. And that's what created the opening for Raft, a solution that was designed from day one with the human developer in mind. And this really is a tale of two algorithms. Before Raft, there was Paxos. Paxos is incredibly important and powerful, but oh man, it is notoriously difficult to understand, let alone implement correctly. So the creators of Raft came along and said, what if we could build something that's just as fast and just as fault-tolerant as Paxos, but make it so people can actually understand it? That was the game changer. And hey, you don't have to take my word for it. It's right there on their website, front and center. It's their mission statement. This focus on understandability isn't just for show. It means fewer bugs and systems that are way easier to build and debug. So how does Raft work its magic? Well, it breaks the whole problem down. At any moment, every single server in the cluster is in one of just three states, or roles. There's always one and only one, leader. This is the boss. It handles all the client requests and tells everyone else what to do. The rest of the servers are followers. They're totally passive. And then there's the candidate. This is what a follower becomes when it thinks the leader has gone missing and decides to run for office. Now that we know the players, let's dig into the first big problem Raft has to solve, choosing a leader. Without a leader, absolutely nothing can get done in a Raft cluster. To keep things organized, Raft divides time up into periods called terms. You can think of these just like terms of office for a politician. Every single term starts with an election. If that election is successful and a leader is picked, that leader is in charge for the rest of the term. If the election fails for some reason, the term ends, a new one starts, and it's time for another election. The whole process is actually pretty slick. So followers are just sitting there listening for these little heartbeat messages from the leader that basically say, hey, I'm still here. If a certain amount of time goes by, the election timeout, and a follower hasn't heard anything, it assumes the leader is dead, so it springs into action. It switches its role to candidate, bumps up the term number, votes for itself, and then sends out a message to all the other servers asking for their vote. If it gets votes from a majority of the servers, boom, it wins. It's the new leader. Okay, but you might be wondering, what happens if a bunch of servers all notice the leader is gone at the same time? Couldn't they all become candidates and split the vote so no one wins? Well, Raft has this really simple, really brilliant solution, randomized election timeouts. Each server picks a random timeout period. That tiny bit of randomness makes it super likely that one server will time out just a little bit before everyone else, start an election, and win it before the others even get a chance to become candidates. So clever. Okay, so we've got a leader. Awesome. Now comes the second critical job, making sure every server's log of commands is a perfect, identical copy of the leader's. This is the real heart of Raft. It's called log replication. So here's how it goes down. First, a client sends a command like update this value to 10 to the leader. The leader adds that command to its own private log. Then it sends that new log entry out to all of its followers. And now it waits, and this is the key. Only when a majority of the followers write back and say, "Yep, got it," does the leader then commit that entry. That's the point of no return. Once it's committed, the leader applies the command and tells the followers they can do the same. That majority rule is what guarantees that a decision will survive, even if a few servers fail. Raft also has this really powerful safety net. Let's say a leader crashes before it can tell everyone an entry is committed. Well, when a new leader is elected, it becomes the one and only source of truth. It will literally force all the followers to match its own log, even if it means they have to throw away some entries they might have. This ensures the whole system snaps back to a consistent state super quickly. Now, I know this might all sound a little bit abstract, but the reason we're even talking about Raft is because it is absolutely everywhere, powering systems you almost certainly use every single day, whether you know it or not.
Seriously, this is not some toy algorithm from a textbook. The fact that it's both simple and provably safe has made it the #1 choice for building the infrastructure that our modern world runs on.
I mean, just look at this list. We're talking about etcd, which is literally the brain of Kubernetes. We're talking huge data systems like Kafka and popular databases like MongoDB and CockroachDB, RabbitMQ, ScyllaDB, the list goes on. Raft is the engine under the hood that keeps all these things running reliably. So if we boil it all down, what makes Raft so great? Well, first, it's understandable. That was the whole point, right? It makes it easier to build things correctly. Second, it's proven safe. It's been formally verified to guarantee things like you'll never have two leaders in the same term. And third, it's just plain practical. It gives you a complete recipe for building a real-world system. Of course, no system is perfect, and it's fair to point out Raft's trade-offs. Because everything has to go through one leader, that can sometimes be a performance bottleneck. It also assumes servers will fail by crashing, not by turning evil and lying. So it's not built for hostile environments like public blockchains. And actually changing the members of a running cluster, well, that can get pretty tricky. And that kind of brings us full circle to this final thought. The wild success of Raft really tells a powerful story. It suggests that as we build more and more complex systems, maybe the most important feature isn't just raw speed or power, but clarity. In a world of growing complexity, could it be that understandability is actually the ultimate feature? It's definitely something to think about. Thanks for joining me on this one.